Hi everyone, this is Srikanth S, Assistant Professor of Triple Department. In this session, I'm going to cover the problems on equivalent resistance. That is, when the resistances are connected in series and parallel, how we are going to calculate the equivalent resistance between the two terminals we are going to discuss. Here, when the resistors are connected in series, when the resistors are connected in series, R equivalent is equals to R1 plus R2. When the resistors are connected in parallel, the R equivalent will be equals to R1 R2 by R1 plus R2. These are the formulas which we are going to use for calculating the equivalent resistance. So when we are calculating the equivalent resistance, first we need to check what are the terminals are given for calculating the equivalent resistance. Here this is the circuit which is given. These are the terminals. Let us consider these terminals as X, Y. So these are the XY terminals or points from which we need to calculate the equivalent resistance. If the terminals are given left side, we have to start calculating the equivalent resistance from the right side. If the terminals are given right side, we have to start calculating the equivalent resistance from the left side. So here, if you see this 4 ohms, 5 ohms and 3 ohms, these three are connected in series. So 4 ohms, 3 ohms and 5 ohms are connected in series. When the resistors are connected in series, R equivalent is equals to, let us consider this as R equivalent 1, that is equals to 4 plus 3 plus 5. 5 plus 3, 8 plus 4, 12 ohms. This is our R equivalent 1. Now let us replace the circuit with this 12 ohms. That is, here our circuit is replacing with the 12 ohms by replacing all the three resistors. Here is the 12 ohms, 4 ohms, 3 ohms, 6 ohms, 4 ohms and 3 ohms. This is X1. This is R equivalent. So here this 12 ohms. Now if you see from this side, this 12 ohms and 4 ohms are connected in parallel. That combination is in series with the 3 ohms. So let us take the R equivalent 2 is equals to 3 plus 4 is in parallel with 12 ohms. That is equals to 3 plus 4 into 12 by 4 plus 12, which is equals to 3 plus 48 by 16, which is equals to 6 ohms. Now we got the R equivalent to as 6 ohms. Now let us replace these three resistors with the single resistance 6 ohms. That is 4 ohms, 6 ohms, 6 ohms, 6 ohms, 4 ohms, and 3 ohms. Now if you see, these two resistors are in parallel, X and Y. Here R equivalent 3 is equals to 6 into 6 by 6 plus 6, which is equals to 3 ohms. Now by replacing these two resistors with a 3 ohm resistance, our circuit will become only, which consists of 3 resistors, 3 ohms, 4 ohms, and 3 ohms. This is X, Y. This is the R equivalent. So R equivalent is equals to 4 plus, now these 3 are connected in series, 4 plus 3 plus 3, which is equals to 10 ohms. This is the equivalent resistance of the given circuit. Now let us go with the another problem. Here the terminals are given A and B. So the R equivalent we need to calculate. So the left side are the terminals. So we have to start from the right side. Here this 1 kilo ohm and 1 kilo ohm are connected in series. 1 kilo ohm and 1 kilo ohm are connected in series. In series. So R equivalent 1 is equals to 1 kilo plus 1 kilo, which is equals to 2 kilo ohms. Now let us replace the circuit with this 2 kilo ohms. That is 2 kilo ohms, 2 kilo ohms, 1 kilo ohms, 2 kilo ohms, 1 kilo ohms. This is A and B terminals. So here if you see the circuit, this 2 kilo ohms and 2 kilo ohms are connected in parallel. So the R equivalent 2 is equals to 2 kilo into 2 kilo by 2 kilo plus 2 kilo, which is equals to 1 kilo ohms. Now again the circuit will become here 1 kilo ohm, 1 kilo ohm, 2 kilo ohms, and 1 kilo ohms, A and B terminals. Here this 1 kilo ohm, 1 kilo ohm, 2 kilo ohms, that is connected in parallel with 2 kilo ohms. So here this 1 kilo ohm and 1 kilo ohm are connected in series, so that our 1 kilo ohm and 1 kilo ohm are connected in series. So R equivalent 3 is equals to 1 kilo plus 1 kilo, which is equals to 2 kilo ohms. Now the circuit will become This is 2 kilo ohms, 2 kilo ohms, and 1 kilo ohms. This is A and B. Now RAB is equals to, these two are connected in parallel, that is in series with 1 kilo ohm. So 1 kilo ohm plus 2 kilo in is in parallel with 2 kilo, which is equals to 1 kilo plus 2 kilo into 2 kilo by 2 kilo plus 2 kilo, which is equals to 1 kilo plus 1 kilo, which is equals to 2 kilo ohms. That is nothing but 2000 ohms. This is the another way of another circuit how to calculate the equivalent resistance. This is the another circuit which is having the terminals are not on the left side, not on the right side. So for this type of problems, first we need to solve the parallel connections, and then after we need to check with the series combinations. So in the first branch, that is between C and D, we are having 4, 6 and 12 ohms. These three are connected in parallel. So 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3, which is equals to 1 by 4 plus 1 by 6 plus 1 by 12. So 1 by R equivalent is equals to, so R equivalent is equals to, now we got the R equivalent value as 2 ohms. This is, let us consider this value as R equivalent 1. That is corresponding to this particular parallel branch. That is 4 ohms, 6 ohms and 12 ohms are connected in parallel. Now here in the other branch between E and F, 5 ohms and 20 ohms are connected in parallel. So R equivalent 2 is equals to 5 is in parallel with 20, which is equals to 5 into 20 by 5 plus 20, which is equals to 100 by 25, which is equals to 4 ohms. Now let us replace with R equivalent 1 and R equivalent 2. So the circuit will become C, D, E, F. Here 1 ohm, 3 ohm, 2 ohms. Now this is 4 ohms we got, and this is 2 ohms. Now RCD, which is equals to 1 plus 3 plus 2, which is equals to 6 ohms. REF is equals to 2 plus 4, which is equals to 6 ohms. Now RAB, this is RAB is equals to RCD is in parallel with REF. RAB is equals to RCD is in parallel with REF, which is equals to 6 ohms is in parallel with 6, which is equals to 3 ohms. 6 into 6 by 6 plus 6, which will gives us 3 ohms. This is the way we need to calculate when the circuit is given in a different way. Here, this is the another circuit which is given in a different format. So Here are the terminals which are given. Now we have to start from the right side. That is, here this 10 ohms and 2 ohms are connected in 10 ohms and 2 ohms are connected in series. 10 ohms and 2 ohms are in series. So R equivalent 1 is equals to 10 plus 2, which is equals to 12 ohms. Now our circuit will become, this is 12 ohms, 6 ohms, 8 ohms, 6 ohms, 4 ohms, 8 ohms, 4 ohms, 8 ohms, and 6 ohms. A, B. Here are the terminals. Now, if you see this circuit, this 8 ohms is in parallel with, sorry, in series with 6 and 12 parallel combination. So, I'm taking the two steps at a time. So, the R equivalent 2 is equals to 8 plus 6 ohms is in parallel with 12 ohms. So, 8 plus 12 into 6 by 12 plus 6, which is equals to 8 plus 72 by 18, which is equals to 12 ohms. 8 plus 4, 12. Now this is the R equivalent to. Now let us replace the circuit with R equivalent to. So this is 12 ohms, 6 ohms, 4 ohms, and 4 ohms, 8 ohms, 8 ohms, and 6 ohms. Now if you see, this 6 ohms and 12 ohms are connected in parallel, that is in series with this 4 ohms. Okay, so R equivalent 3 is equals to 4 ohms, 4 plus 6 is in parallel with 12. So 4 plus 6 into 12 by 6 plus 12, which is equals to 8 ohms. Now we got the this equivalent resistance, we got it as 8 ohms. Now if we replace with this R equivalent 3, our circuit will become, this is the 8 ohms, 8 ohms, 4 ohms, 8 ohms, and 6 ohms. REAB. Now, if you see this circuit, this 4 ohms is connected in series with the parallel connected 8 ohms and 8 ohms. So, R equivalent 4 is equals to 4 plus 8 is in parallel with 8. That is 4 plus 8 into 8 by 8 plus 8, which is equals to 8 ohms. Now we got the R equivalent 4 as 8 ohms. Now our circuit will become a 6 ohms which is connected in series with two parallel connected 8 ohms. 8 ohms, 8 ohms and 6 ohms between A and B. Now RAB is equals to 6 plus 8 is in parallel with 8, which is equals to 6 plus 8 into 8 by 8 plus 8, which is equals to 6 plus 4, which is 10 ohms. This is the equivalent resistance of the given circuit. Now this is the another circuit in a different way which is framed. We need to calculate the RAB. So for that, here we need to calculate first series combinations. Then after we need to go with the parallel combination of resistors. So if you see this 3 kilo ohms and 3 kilo ohms are connected in series, and here 3 kilo ohms and 3 kilo ohms are connected in series, and here also 3 kilo ohms and 3 kilo ohms are connected in series. Here also 3 kilo ohms and 3 kilo ohms are connected in series. So all the 3 kilo ohms and 3 kilo ohms are connected in series. Series. So R equivalent 1 is equals to 3 kilo ohms plus 3 kilo ohms, which is equals to 6 kilo ohms. Now we got the R equivalent 1 as 6 kilo ohms. So wherever we are having the series combination of 3 kilo ohms, I am replacing with 6 kilo ohms. Now our circuit will become 6 kilo ohms, 6 kilo ohms, 4 kilo ohms, 6 kilo ohms, 6 kilo ohms, and 4 kilo ohms. Now, if you see these two 6 kilo ohms and 4 kilo ohms are connected in 6 kilo ohms and 4 kilo ohms are connected in parallel. 4 kilo ohms and 6 kilo ohms are connected in parallel. Parallel. Now, the R equivalent 2 is equals to 4 into 6 by 4 plus 6. That is equals to 24 by 10, which is equals to 2.4 kilo ohms. Now, if we replace these two parallel combinations with 2.4 kilo ohms. Now our circuit will become This is A, B, 2.4 kilo ohms, 6 kilo ohms, 2.4 kilo ohms, and 6 kilo ohms. Now our circuit between RAB, which is these two, are connected in series. 6 kilo ohms and 2.4 kilo ohms are connected in series, and that combination is connected in parallel. So here R equivalent 3 is equals to 6 plus 2.4, which is equals to 8.4 kilo ohms. This is our R equivalent 3 which we got for one set of branch, where RAB is equals to 8.4 into 8.4 by 8.4 plus 8.4, which is equals to 4.2 kilo ohms. This is our equivalent circuit resistance for this typical connections. Now let us go with another example, that is here 10 ohms and 15 ohms are connected in series, that is R equivalent 1 is equals to 10 plus 15, which is equals to 25 ohms. Now if we replace our circuit with this 25 ohms, 25 ohms, 30 ohms, 20 ohms, 15 ohms. Now if you see this A and B terminals, this 30 ohms and 25 ohms are connected in parallel. So R equivalent 2 is equals to 30 into 25 by 30 plus 25, which is equals to 13.63 ohms. This is our R equivalent 2. Now if let us replace this circuit with this R equivalent 2, that is that is 15 ohms, 20 ohms, and 13.63 ohms, RAB. So RAB is equals to, here this 15 ohms is connected in parallel with the series connected 20 and 13.63 ohms. That is equals to 15 into 33.63 by 15 plus 33.63, which is equal to 10.37 ohms. This is our equivalent resistance between A and B terminal. In this session, we have discussed several problems on equivalent resistance by using series and parallel equivalent resistance concept. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.